This is Algebraic Reasoning, Chapter 1.2, Exercise 11 through 20. This is going to be about linear functions still. And I'm going to do problems 11, 12, 17, and 19 in this set. For questions 5 through 16, determine whether or not the relationship shows a linear function. If the data set represents a linear function, write the equation for a function. And on the left, we see that we have advancing input values of 2 at each turn. So we're going up by 2 every time as we go up. Now on the right side, we have plus 1 here, between 5 and 7, 7 minus 5 is plus 2, 7 to 10, 10 minus 7 is plus 3, then we have plus 4. Oh, plus 4. So we have, since we do not have a common difference, what do we know by that? We do not have a linear function, or we have a nonlinear function. Function here. And really, that's all there is to it. So that's problem number 11. And we go on to problem 12. Okay, we have, again, like we had in problem 11, we have these increments going up here by 2 at every turn, and so on. And on the right side, we're going up by 1, so plus 1, plus 1, plus 1. Now what we have is, to find our slope, we take the difference, the common difference on the right side, and since we do have a common difference, we have a linear function, divided by the difference on the left side, which we see is 2 up 2 every time, right? So our m is going to be our change in y divided by our change in x, or 1/2. And we have now we have a point. We can use any one of these 5 points, but the point that I'm going to recommend using is the first one here, 0, 8, or the y-intercept. Why? Arithmetic's a little easier. So the point slope form, again, if you watch the predecessing video lesson, you would see the point slope form to be y minus y1 equals m times quantity x minus x1. So we will say m is 1/2, x1 is 0, y1 is 8. So just going ahead and plugging these in, we have y minus y1, which is 8, equals m, and m we have determined to be 1/2, and we have x minus x1, which is 0, which simplifies to y minus 8 equals 1/2 x. And if we add 8 to both sides of this equation, we get y equals 1/2 x plus 8. And we could try this for any one of them. We can say, okay, for this, we can try any point. 8, 1/2 of 8 is 4. 4 plus 8 is 12, and so on. We can check these out for different situations. They will all check out. And this is our correct answer. Now we're going to go on to problem 17. Okay, for questions 17 to 20, use the information in the problem to create a table of value, a table of data, then use the table to determine if the situation is linear or not. If the situation is linear, then use the table to determine the linear function. And the elevation of Lake Sam Rayburn is 164 feet above sea level. So we will say at time, okay, we're going each week. So X would represent here the weeks, right? And then Y would represent the feet above sea level. Just writing the units up above here. So at initial time, we will say at time equals 0, we have 164 feet above sea level. And then we are decreasing as we go up. We are decreasing 0.5 feet. So after the 164 minus 0.5, we're going to have 163.5. And then after week 2, we're going to subtract another 0.5 feet. We're going to have 163 feet elevation. At week 2, week 3, we're going to subtract out another 0.5 feet. So we're going to get 162.5 feet. And then at week 4, we're going to subtract another 0.5 feet, so we get 162 feet. Okay. And then if the situation is linear, okay, since there is a common difference, and really from the word problem, we know it says 0.05 feet each week. That tells us right there that we have a linear situation. We have a linear function. Now, I used point slope form earlier, but now for this one, I think because we have a y-intercept, I'm going to suggest using the slope intercept form. So I'm going to just read that slope intercept form. And that's going to be y equals mx plus b. Well, m is going to be how much this decreases. The level decreases every week, so it's going to be m equals negative 0.5. And our b, our y-intercept, is going to be 164 feet, because at x equals 0, we have 164. So using our values here, we're going to say y equals negative 0.5 x plus 164 feet. And if we want to go ahead and make it use w for week and height in feet for h, we could say the height is equal to negative 0.5 times the number of weeks plus 164 feet, which is our initial height. So I'm going to say this is our correct answer for number 17. Next, 19. According to a recent health department survey, there were 750 mosquitoes per acre in a county park. After a recent rainstorm, the number of mosquitoes doubled every 2 days. So at time 0, we say we have 750 mosquitoes. And 2 days later, we have doubled that 750. I'll just put a parentheses 2. 750 times 2 is going to be 1,500. And then 2 days later, we're going to double again that 1,500 mosquitoes to get 3,000 mosquitoes. Double again, we have, after 6 days, 3,000 times 2 will be 6,000 mosquitoes. And then finally, one last time, we double to get to day 8. After day 8, we will have 6,000 times 2, or 12,000 mosquitoes. So these are not common differences. This 2 is a common ratio. 2 is not a common difference. But instead, a common ratio. Ratio is what I meant to put down. And we say, therefore, ... triangular dot, not linear. Okay, that's that. These are all the problems I'm going to be doing in this set. Good luck with all these other problems. And thanks for viewing.